Welcome to the 8th video of Section 3. We have now covered a lot of low-level details and used them to build high-level page objects. Let's now continue with some advanced WebDriver features. We'll cover the complexity of modern, responsive web applications that will require interacting with all the different types of components you will find on a web page. In this video, we will focus on some of the advanced WebDriver features with examples. Radio buttons have the property that only one can be selected at a time. When a radio button is selected, all the other radio buttons in the same group are unselected. A radio button group is a collection of all radio buttons that have the same name. To find out which one is selected, we need to do two things. We need to find all web elements with a given name, and we need to iterate over these elements and remember the selected element. Let's look at an example. W3 Schools has a lot of HTML examples. Let us look at their page for forms and input. Here we have a simple radio button group where we can select either male or female. Let us input a small example where we check if the male option is selected or not. Radio button example test. This example is implemented as one single class. Instead of implementing a page object, let's divide the navigation and validation into different methods. This is for navigation, and this is for verification. The first thing we must do is to make sure that it is translated to the desired page. When we select a radio button, a male is selected by default. The actual test does two things. First, it delegates the interesting part of locating the radio button. Second, it verifies the result. Interesting things happen here. I locate the radio button group by searching for all elements with the same name, sex, on the page. With all elements in a list, we will iterate over all of them. If we find a selected element, we will return the value found in the attribute called value. This is how you work with radio buttons. Find the set of all radio buttons, iterate over it, and do something with one of them. Let us run the test individually here and observe the result in the console. The test has passed, and the result is showing as expected in the console. The number of buttons is 2, and male was selected by default. Checkboxes are another input type that we must be able to work with. They are different compared to radio buttons in the sense that they can be selected independently of any other checkboxes. Checkboxes can have none, one, or many selected. Checkboxes are easier to work with. All you have to do is find it and see if it is selected or not. Let us take a look again at W3 Schools and implement an example where we interact with two checkboxes. On W3 Schools site, we can see two checkboxes to interact with, and both of them are unchecked. Let's inspect the element with Firebug. After taking a closer look, reveals that the name of one checkbox is Vehicle 1 and the other is Vehicle 2. It is easy to identify and locate each checkbox as they have a unique name. Let's implement a small example. Open Checkboxes Example Test. We will verify whether the checkboxes are tick-marked or not. Our expected result should be false, as both checkboxes are unchecked. Let's run the test. The test has passed, and the expected result is shown. Both the checkboxes show false. Many of these advanced interactions have great support in the org.openqa.selenium.support.ui package. Let us look at some of the goodies located there. Let's start with the Select class. It models a select tag and provides helper methods when working with selects. Let us take a look at a page where we will find a select at W3 Schools. This is a test page from W3 Schools, where you can fiddle around with a select and try different things. Let's implement a small example where we can check which option has been selected from the drop-down box. And we shall get all the items of drop-down by iteration. We will follow the same pattern from the previous examples. Let us run the select example test individually and observe the result. It has passed and shows first selected item, number of items, and list of all combo items. Now, let us concentrate on wait for page loading in Selenium WebDriver. What should we do when a page takes time to load? Suppose that we send a request that takes some time to execute. We want to verify something on the resulting page. We will have to wait for the page to load. Just locating the wanted element after the request was sent doesn't work. Let's implement a search on Google. We will count the number of results we get when we search for Selenium WebDriver. This should be a simple thing, but it turns out that it isn't as easy as one would hope. We have three methods. Should wait for page to load 1, 2, and 3. Let's implement them one by one. Let's implement the first one and execute the test. Let's go see the result. Well, the first one fails. We have called the first method from our test method. Let's run it. Well, it's failed. Now what? How can we slow down the test so the page has been loaded? Let's add a sleep method before we try to locate the result area. We will implement the sleep method in a second method. Let's call our second method from our test method. Should wait for page to load 2. Let's run this example again. It should pass, as we have waited for 1000 milliseconds before loading the page. Awesome! It passed, which means it worked. That solves everything, right? Not really. This sleep will always be executed, even if the result is returned faster than the time slept. The solution will not handle efficiently if the loading takes longer time than the sleep timer either. Adding sleep time is actually a bad idea. The sleep time in your tests will add up, and the already slow tests will be even slower. What should we do then? We should use the WebDriver wait and wait until the wanted element is found on the web page. We have implemented the WebDriver wait method in our third test. Let's call this method from our test method and run the test again. This test should pass. It did. Cool, right? The problem is solved, and in a good way this time. Failures will always occur. The most important thing when a failure occurs are the parameters used, an execution log where it is easy to follow a flow, and a screenshot of the web browser. The screenshot may be the single most important clue when the reason for the failure needs to be understood. Let's see an example where we take a screenshot on a failing test. There are two things that have been done. First, do something on failure. Second, take the actual screenshot and save a file with it. Acting on failure is JUnit specific and will probably be done differently if you use another framework. Creating a screenshot is done with WebDriver and is therefore similar even if you use another framework, such as TestNG. My idea is to implement a JUnit rule that will be triggered whenever a test fails. The real work will be done in the rule. Let's implement that as well. So we have implemented a screenshot rule here, and we have also created a test class called Screenshot Example Test. Actually, at the rate, rule impression will do the magic. When a test fails, it will be called Screenshot Rule. So, in our test class, we have implemented a LinkedIn registration, and intentionally we have made an error in the ID of last name so that it should fail. And when a fail occurs, a screenshot will be captured in our desired location. Let's run the test and see the result. As we can see, the test has failed and a screenshot has been captured. Let's check the reason for this error. It says, unable to locate element, method ID, selector, last name. The test was created because of the ID of last name was incorrect. In this line, let's observe the screenshot that has been captured in the desired location. In our case, the screenshot will be placed at the following location: D, Drive, Test folder. Let's see the screenshot. Cool. Now we have a screenshot whenever a test fails. In this video, we've taken a look at a few advanced features of WebDriver. It happens that you need to move between different windows when testing a web application. In this video, we'll aim to resolve this issue and see a few more features. Let us see an example of how you can hold a list with all windows available and then change the focus between them. We will implement an example where we open up two windows in Firefox, open up the Google search page in one of them and Bing in the other. This is the multiple window example. Here we have two methods: open first window and get new window. In the first method, we'll open google.com, and in the second, we'll open bing.com. We have to save the window handle for the first window before we can create the other window. We will do this so we can switch between them afterwards. With two window handles pointing at two different windows in Firefox, we can call the switch2.window open brackets close brackets method with the window handle to which we want to give focus. After opening the Bing window, we will switch to the Google window again by using driver.switch2.window and the parameter in the window Google, which is a variable of window handle. Let's run it. The first window is Google, and the second is Bing. And again, we have focused on Google. Let's observe both windows. So, it worked. Great, isn't it? It turns out that this is very similar to the way you move between iframes as well. Let's go back to the select example and look at the switch2.frame. In this case, we didn't have many windows to handle, but we did have an iframe to move ahead if we could find the select that we were looking for. I wanted to open up a new window in the previous example. One way to do that was to execute the JavaScript. Window.open. WebDriver supports running JavaScript if the browser you use supports JavaScript. The JavaScript will be executed in the same context as your current window or frame. This means that we were able to get a new browser window when we did window.open. Let us examine the getNewWindow method. In the multiple windows example test, we will start with casting the browser into a JavaScript executor. This will fail if the browser doesn't implement the JavaScript executor interface. When we have a JavaScript executor, we should invoke our script through the execute script method. Looking at the Java doc, let's observe the JavaScript executor interface. It tells us that most browser drivers implemented. We have seen many different ways for locating elements on a web page. We haven't seen any example where we use XPath. But before we dive into an example, let's get familiar with what XPath is. XPath is a search language that you can use for searching in XML documents. HTML is XML too, so searching for elements in HTML can be done using XPath. There are two problems we may encounter while executing a search using XPath. The first one is that the slightest change in the structure of the web page can affect the result and makes your XPath search invalid. The second one is that it is a lot more complicated as compared to locating elements using their name or ID. An XPath tutorial can be found at the following link. It is out of scope for this video course to go through all the details about XPath. However, you can go through the link and learn on your own. There are tools that will help you to find the XPath to an element. I use Firebug a lot for examining web pages. A Firebug extension is called FirePath, and it will allow you to search in web pages with XPath. It is nice, but the killer feature of FirePath is the possibility to point an element and get the XPath for it. Let's see an example on how we can locate the heading XPath tutorial with FirePath. This is the XPath tutorial heading. Right-click on XPath tutorial, inspect in FirePath, and look at the search box. The XPath of XPath tutorial heading will be displayed in the search box. With the XPath we want, let's implement an example that locates the web element. We have implemented one example, XPath example test, by using the XPath that we have examined using FirePath. Let's run it and ensure that we actually get the text XPath tutorial. Whoa, we got it! The heading of XPath tutorial can be seen here. This may not seem much more complicated than locating elements using the methods we have covered so far. Depending on your mileage, it may not be more complicated either. But using paths has a definite downside, and it is a fact that it uses the path structure to locate things. This means that a small change on the page can easily break everything. In other words, it may be unnecessarily fragile. I wouldn't recommend using XPath unless you really can't find the element any other way. Sometime it might need to use absolute XPath rather than relative XPath. CSS and XPath can be used as element identifiers. Both CSS and XPath of an element can be obtained by using FirePath. Moreover, CSS is faster than XPath, so it's good to use CSS rather than XPath. There are many ways to interact with a modern web application. This short walkthrough is not the end, it's just the beginning. It should have given you enough so you can start using them, but at the same time, I'm sure you will find special cases that will be challenging to resolve, that we haven't covered here. Radio buttons, which find all and iterate over them. Checkboxes, not really advanced unless they are all named the same thing. Select. Use org.openqa.selenium.support.ui.select. Wait. Wait for the object to show up. Never use sleep. Screenshot on failure. Done differently in different test frameworks. Invaluable when troubleshooting. Multiple windows. Save the window handles and switch between them as you need. JavaScript will be executed in the context of the current browser. XPath, powerful and fragile. Use with care. So in this video in all, we've covered 8 different cases. There are obviously more, but this will hopefully be enough to get you a running start. We will connect all the dots with the reality in the next video of this section. We will build an entire example with Maven. Join me there.